Greatest common factor of monomials. The key to finding the greatest common factor is to know your prime numbers. The key to knowing how to factor to find your GCF is to know it's also to know your factors. So our prime numbers, what we're looking for is 2, 3, 5, 7, 11, 13, 17, 19, 23, and it goes on. Typically, these are the ones that we stop with. It can be larger. Tomorrow we'll encounter some numbers that aren't on this list. So you need to have a good understanding of your prime numbers. And all you do is factor. So let's start off easy. Are you ready? Prime factorization. Prime factorization, it's when you divide a value It's when you divide a value. So if I had the number 100, you can divide that value into anything. 10 times 10, 2 times 50, whatever you decide to do. So you divide a value, and then you continue to divide the factors until all factors are prime. So it's just repetitive division, over and over and over and over and over until you can go no more. And the great thing is I can start one way and Angelina can start the other way and we'll end up with the same answer. It does not matter how you begin. If we had the number, for example, 60. I could say 6 and 10. My favorite is anytime a value ends with a 0, I divide by 10. Tommy could say, no, it's even. I like to divide every even number by 2. Doesn't matter. He and I will end up with the same value. If we went the 10 route, 10 times what is 60? 10 times 6. And I look, are either of these numbers prime? No, so I can continue to divide. What times what is 10? 5 times 2 is 10. Is there any other combination that would have worked? No. Is 5 in my list of prime numbers? Yes. So I'm going to circle it because I'm done. And is 2 in my list of prime numbers? So I'm done. Now let's go back to 6. What times what is 6? 3 times 2. And I look at my list of prime numbers. Is 2 a prime number? Or 3? Yeah. And 2. So the prime factorization of this would be 2 times 2 times 3 times 5. If you wanted to write it exponentially, you could as 2 squared times 3 times 5. That is the prime factorization. This is going to get you further with GCF than your simplified exponential answer. But do you think it's going to be this easy? No. No, because this is a GCF of monomials. So what do you think we need to add in? Exponents. So let's just factor a monomial. 32 x to the third. Now to do this problem, you have to break up the coefficient and the variables. We have to separate them. You'll get to the point that you may not need to rewrite it separate, but to begin with, writing them with a space between them is really helpful. So I have 32 and I have x to the third. So we have to factor 32 first. And again, you can go any factors. Sometimes you need a calculator if it's a number you're not familiar with and you do the whole guess and check if you don't know your divisibility rules or your factors off the top of your head. The go-to, is it even? Yeah. If it's even, you can always divide by 2. 32 is 2 times what? 16. Is 2 prime? Yep. Is 16 prime? Nope. No. You can go 2 ways. What's one way of dividing 16, Samantha? 2 and 8. What's another way of dividing it, Angelina? 4 and 4. Both will get you the same answer. If I went 2 and 8, is 2 prime? Yep. Is 8 prime? Nope. So let's divide 8. 2 and what? 4. 4. Is 2 prime? Yep. Is 4 prime? What can 2 become? Is 2 prime? Is 2 prime? I'm done factoring. Let's go back to my x to the third. X to the third breaks down. If I take out 1x, what's left behind? 2x. X squared. Can you break down x squared? Yes. To x and x. Since there are x to the third, I need 3 x's. So the prime factorization of 32 x to the third is 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. Angelina. You can simplify into exponential information, but it's not going to get you to where we want for greatest common factor. Do you understand factoring? The only new part should be the exponent part, correct? All right, so let's try what you're going to see on homework. We're going to incorporate the GCF now. And GCF stands for greatest common factor. Greatest common factor. So all we're doing is we're looking for the biggest common factor, the factor they share that's the same. Except there's a little bit of a twist. These are the steps you follow. You're going to find the prime factorization of each monomial. After you do that, you're going to multiply the factors they share. You want to practice? 66 yx is your first monomial. And your second monomial is 30x squared y. So the first monomial is 66yx. The second one is 30xy, x squared y. So we're going to split them apart. What should I split 66yx into? Angelina? 66 is the first part. Then y is by itself. And then x is by itself. I separate everything. Let's factor 66. 2 and 33. What's another way if you wanted to go? 6 and 11. Two is prime. Is 33 prime? What? Angelina? 3 and 11. Is 3 prime? Is 11 prime? Since y is all alone, I can't factor it, I circle it. You can only factor a variable if it has an exponent. So can you factor x? Nope. All right, let's do the factoring for 30x squared y. What does 30x squared y separate into? 30. X squared and y. 30's got a couple different ways to factor. Keegan, what's one? 3 and 10, what's another? 15 and 2, there's a third. 5 and 6. All three will get you to the same answer. 3 and 10 is the first one I heard. Is 3 prime?
Yep.
Is 10 prime?
No.
Factor 10. 5 times 2 is 5 prime?
Yep.
Is 2 prime? Yes. Done with 30. Move to x squared. Can x squared be factored?
Yes.
To what?
X.
X and x. Y is by itself, so I circle it. You prime factor each monomial. Done. We multiply the factors they share. So if I look at the circled values, what do they share? Angelina, what's one thing they share? A 3. Do they share anything else? Who can tell me? Jesse, one more thing. They share 2's that are circled. Tommy. They share an X here and an X here. Because there's only one X in the first monomial. So I can't do 2 X's in the second monomial. They only share one X value. Keegan? And they share a Y. There's one Y here. There's one Y here. Angelina, if this was 2 X's, there were 2 X's circled over here, then I could highlight both of them. So I look, what do they share? I've marked everything they share. I'm going to cover up 1 because I only care about one set of what they share. They share a 2. They share a 3. They share an X. And they share a Y. To find the greatest common factor, we simplify this. Two times 3 is 6 XY. The greatest common factor of those 2 monomials is 6 XY. Correct. Or you could factor for 3, but you only have one monomial as your answer. Questions?